Um, Good evening, everybody, and I'd just like to thank AHDB for inviting me to give this webinar and for taking an interest in the work that we're doing in UCD at the minute with regards to forage maize research. I'd just like to take this opportunity to thank my co-authors. As usual, these are usually the guys doing the hard work in the field, and also to the funders of the work that we're doing forage maize in UCD at the minute, Enterprise Ireland, SAMCO, Teagasc Walsh Fellowship, and the Irish Farmers Journal. So as a bit of background, I guess I'll just give you a quick snapshot of forage maize in Ireland as it currently stands with regard to area sown, the use of film, where it's grown, and it'll give you a bit of background as to, I guess, why we're doing the agronomy work that we're doing and the questions that we're trying to answer. So as you can see from this graph, shows the hectares of forage maize grown in Ireland from 2004 up to 2014. You can see that the area increased steadily from 2004 to about 2009. And I guess that was due to advances in varieties, so more suitable varieties for a marginal environment in Ireland, and also I guess increase in interest in the crop as a forage source in Ireland. Due to difficult growing conditions and a poor growing season in 2009 and 2010, we've seen a significant decrease in area grown, and really it's leveled off over the last number of years. 2015 there was just over 12,200 hectares of forage maize grown in Ireland. It's expected, I guess, that the area might increase in the next number of years with our increase in dairy herd in Ireland at the minute. Even though the area, I guess the total area has decreased, what we've seen is a big shift in the area being sown with and without film or degradable plastic mulch. So this graph, the bars in yellow show maize grown with no film or maize grown in the open, and then the white bars show maize grown with film. So from the mid to late 90s up to present day, I guess the area being sown with film has increased and the area being sown in the open has decreased. And now it's estimated about 85% of the forage maize that is sown in Ireland is sown with film. So I guess why do we use film, or why is most of our maize that is sown in Ireland uses film? Film or degradable plastic mulch, I guess, creates a glasshouse effect in a marginal environment, and really it has resulted in, I guess, the reduction in variability of maize quality and quantity from year to year. So I guess we have a more consistent feedstuff from both a quantity and quality point of view from year to year. And in a poor growing season like last year, it's a real insurance policy. Maize grown in the open in 2015, much of it was crop failure. There was something to salvage with maize grown with film, so you'd hope to get at least 25% starch in a poor year. So I guess other benefits of film, you get to sow the crop earlier. So in Ireland we would sow from the start of April, just once we would have favourable seedbed conditions, and we would look to harvest that in early to mid-October, again depending on maturity and harvesting conditions. But basically it means we can get it out of the field earlier before weather conditions turn poor, and I guess for some people they could perhaps follow on with another crop at that stage. So I guess another benefit is being able to get it out of the field earlier. This map just shows where forage maize has been grown in Ireland. So the darker orange colours show an increase in area. So it very much follows where we have suitable weather conditions and where we have suitable soil types, and also it maps where the dairy concentrated parts of Ireland are. So very much along, this would be sort of winter milk production, and then along the east coast, the southeast and southwest where we would have favourable growing conditions, but also where there would be concentrated with regards to dairy cows. So I guess because of the reduction in area grown in Ireland, I guess we thought from a research point of view that we needed to improve the decision making for forage maize growers in marginal environments like Ireland. So we revisited some agronomy factors, and I guess we wanted to optimize agronomy practices to produce high quality forage maize in marginal conditions. So we're looking at a number of factors in UCD. The ones I'm going to concentrate on tonight are the ones that are highlighted in yellow. So film type, site, variety effects, our herbicide program, and also nitrogen rate, timing, and fertilizer type. So we have ongoing work on soil data and seeding rate as part of Eamon Corcoran's PhD. I guess that'll be for another day. So I'm just going to start off with a fairly large-scale trial that we conducted in 2013 and 2014, where we looked at 4 sites in 2013, and 3 sites are going to be presented from the 2014 year. We actually had a 4th site, but one of the reps just wasn't good enough, and so we weren't able to use data from the 4th site. So 4 sites in 13 and 3 sites in 2014. We looked at 3 different film types, so no film, so maize in the open, Samco yellow and Samco green. So Samco have a whole range of variant different film types. They're given a colour just to code them, and the films differ in their degradability. So I guess traditional film for a more marginal environment would be Samco grey. So Samco grey would be less degradable compared to Samco green, and then Samco yellow would be more degradable compared to the green or the grey. So basically they have a range of films to suit a particular environment. So grey and green, more suitable to marginal environments. The yellow then would typically be used in warmer environments for sweet corn production and things like that, where it degrades quite quickly. And then we looked at 5 varieties, so P7905, P7631, P7892, Benicia, and 39A98. I guess those 5 different varieties given us a range in maturity. So this infographic shows the effect of site on whole crop yield, and this includes both film and open treatments. So the dark blue arrow shows the whole crop yields at the 4 different sites, and then within the white text box we've got the energy yields, so starch yields in tons of dry matter per hectare, and also ME yields as well. So we saw that there was a site effect, and this is generally what we would expect. So the more southern sites having a higher yield and also a higher energy yield compared to sites further north in the country. In 2014 we had a similar trend, but this time the northeast site had the highest whole crop yield, and again the energy yields with regards to starch and ME are shown in the white text boxes as well. 2013 and 2014 were very good growing years for forage maize. They were dry, hot summers, which is very suitable to the maize crop with the extensive root system. So I guess in very good years like that, you would expect maybe there not to be much benefit or economic return in growing maize under film versus in the open. So what this infographic shows you is the difference in whole crop yield of maize grown under film, which is represented by the green tags, versus maize grown in the open, which is represented by the red. So we, even in very good growing year like 2013, we still had differences in whole crop yield at the sites when you compare film in the open versus film or maize in the open versus maize grown under film. What I guess where we saw real benefits was in the quality of the crops, and that's what this table shows here. So we've got here is the effect of film treatment on whole crop yield and the chemical composition as well. So our parameters are on the left hand side. So we've got whole crop yield, grain yield, dry matter percentage, ME, starch content, starch yield and ME yield, and then our film treatment, so maize in the open with no film, Samco green, and then the Samco yellow. So just stepping down through them, regards to yield, you can see that there is significant increase in whole crop yield, as we saw previously in the infographic, but where we saw a real difference was in the grain yield, so 4 tonne for the open and about 11 tonne on average for the film treatments with maize grown under film, regards to grain yield. Regards to chemical composition, again, benefits regards to dry matter percentage, ME content, and also starch content of maize grown with film versus open. And then with regards to the quality yield, starch yield and ME yield, higher with maize grown with film compared to the open. We saw similar trends in 2014 as well with regards to the yield, so higher yield with film. Improved chemical composition or nutritive value compared to the open, and again with regards to our energy, the starch yield and the ME yield, higher with maize grown under film versus open. It's worth noting that these were all harvested at the same date, so we didn't have different harvest dates. So you would imagine if you left the open for another 2 weeks or that the dry matter percentage and starch may increase, but I don't think the grain yield or the nutritive value would catch up in that time period compared to the film treatments. So I guess in summary, we were quite surprised with the benefits of using film even in very good growing years with regards to yield and chemical composition. As part of this trial, we also looked at varieties at the different sites. So the varieties, again, just P7905, 7631, P7892 Benicia, and 39A98. And you can see them, their yields at the various sites on the x-axis, so the south, southeast, northeast, and the southwest. So in 2013, I guess if you look at 7905 was the highest yielding in the south, also the highest yielding in the northeast, but no major difference between varieties in the southwest, and sort of a re-ranking there in the southeast. So the 2013 information and also the 2014 data from the site and variety trials sort of reinforce the point of picking a variety and a maturity classification that's suitable to the site in which you're growing it in, because otherwise they, if you're looking at varieties behave differently at different sites, so it's important to pick a variety that's suitable for the site but also for end use as well. So if you're looking for bulk, obviously you might go with some of the latter maturing varieties, or if you're looking for quality, to make sure you're looking at an earlier maturing variety that will increase your starch and your ME content. At the time of doing this work in 13 and 14, Claris was going to go off-label for use under film in Ireland, and so we did some work investigating alternatives or looking at different pre-herbicide options for maize in 2013 and 2014. Now Claris is still on label for film. But still the results are interesting and worth showing the different herbicide products and how they behaved at different sites as well. So for the herbicide trials, we looked at 2 timings, so pre-emergence only or pre-emergence plus a post-emergence herbicide, and we used a variety 7905, and the green film was constant across treatments and sites. So in 2013, we had the 4 sites again, and we had 2 timings, so pre-emergence only or pre-emergence plus post-emergence. And the pre-herbicide treatments were a combination of Stomp Aqua and Claris was treatment 1, treatment 2, Stomp Aqua and Dual Gold, and then the third treatment was Stomp Aqua and Frontier. And these were all with or without a post-emergence herbicide, and that post-emergence herbicide was alpha bromotril P. So just to give you a bit of information, if you're not familiar with those products or their active ingredients, the Stomp Aqua Claris, so the Stomp Aqua, that's its active ingredient there. The Claris, again, its active ingredient, the rates that we used, and the concentration of the active ingredients. Same with the Dual Gold, its rate and the active ingredient. And Frontier, again, its rate and its active ingredient. And they're all the pre-emergence herbicides, and the post-emergence that we used was alpha bromotril P, and that was the rate that we used and the active ingredient as well. So we scored the plots twice in 2013. So before we put on the post-emergence herbicide in June. So what we've got here is a weed score, so it's a visual score on a scale of 1 to 5. So 1 being no weeds presence and 5 being completely covered in weeds. So in addition to the treatments that I just went through there regards to the chemicals, we also had a control where we applied no pre-herbicide. So the control was a 5 on the weed score, and that's just a picture to show you the no herbicide and the consequences of no herbicide. It's completely covered in weeds. So just at the June score, I guess we saw, full effect of all the herbicides compared to the control, but early in the season there's just a marginal benefit of the Stomp Aqua and Frontier compared to the Stomp Aqua and Claris and the Stomp Aqua and Dual Gold. This graph is slightly more complicated because it's conducted in September, and so also contains the effect of the post-emergence herbicide. So the red bars represents the Stomp Aqua and Claris. This is Stomp Aqua Claris on its own plus the post-emergence. The Dual Gold is represented by the blue bars, the lighter one showing the addition of a post-emergence herbicide, and the green is the Stomp Aqua Frontier, and again the lighter colour representing the addition of a post-emergence herbicide. So again, weed scores on a scale of 1 to 5, and you can see that there's side effects. So actually there was quite challenging with regards to bindweed. That site was a particular issue in that year. That site is maize on maize, so just a bit of issue there with bindweed over time. So that was the side effect. The post-emergence herbicide, so there's a tendency for a benefit of the addition of a post-emergence herbicide. And with regards to the pre-emergence tendency, that was favourable with regards to Stomp Aqua and Claris on weed scores in September. In 2014, we again looked at different pre-herbicide treatments. So we looked at Stomp Aqua on its own, Stomp Aqua and Dual Gold again, and then we looked at Stomp Aqua and Wing P. And the post-herbicide that we used this time was Ascent. So again, we applied pre-emergence only or pre-emergence plus post-emergence. So again, just to show you the products, the rates and their active ingredients. There for Stomp Aqua, the rate that we use and the active ingredient of it. Wing P, rate and active ingredients. Dual Gold, similar to the previous year, and then looking at Stomp Aqua on its own, and then at the bottom we have our post-emergence, the Ascent and its rate that was used and the active ingredient as well. So this graph shows the effect of the pre-herb aside on weed scores in June. So on the left is the under film scores, and then on the right is the between row scores. So again, our weed score 1 to 5, a visual assessment. So we found there was a site by pre-herb interaction. So basically some sites there was more of an effect of the herbicide compared to others. The general trends, both under film and between rows, that the stump aqua on its own was least effective compared to the addition of dual gold or wing P, and generally we found that the wing P to be most effective herbicide combination compared to the other two treatments at each of the sites. We also did weed scores in August as well to show the effect towards the end of the growing season. So on the left again is under film, and on the right is between rows as well. So very similar treatments. The stump aqua on its own being least effective compared to if there's an addition of another herbicide like the dual gold or the wing P. And again the wing P being more effective, particularly in sites that had quite a weed challenge like the Wexford site and Bandon as well. We found, and it's not shown there, that the addition of the post-emergence herbicide was beneficial across the board. So just to summarise our herbicide work, we found that stump aqua and frontier, a good control early in the season. Stump aqua and Claris, good control over the growing season. And in 2014 we found that stump aqua and wing P to have very good control, particularly in challenging weed sites. And in both years that the addition of a post herbicide application improved weed control as well. Just moving on to the latter end of the work that I'm going to cover today, and that's looking at the effect of just looking at the fertilizer inputs, particularly nitrogen. So this table gives you an idea of the costs of maize production in Ireland. So it's shown in euro per hectare, so you'll have to do a quick calculation there and trying to convert it into sterling. But overall, if you're producing maize under film, it's about over 16,000 euro per hectare. So the film is about an additional 300 euro. But I guess farmers and the decrease in area of maize grown in Ireland is that it's perceived to be an expensive crop and you may not necessarily get the economic return of it. So we have decided to look at the fertilizer component and see if we can use different types of chemical fertilizer applied at different times to try and make better use of the fertilizer that farmers are applying. So obviously this cost here represents if all of the fertilizer comes from chemical sources. A lot of farmers obviously have access to slurry, so that would reduce your cost, but I guess you still have some amount of chemical nitrogen that needs to be applied. This is just the trend in fertilizer prices from the 1990s to present day. So the general trend is that the cost of urea, CAN or compound is increasing. Obviously can fluctuate from year to year, but the general trend is that is increasing. So I guess the question is, can we use it more strategically in the production of forage maize to get more out of our investment? So we started this work in 2013 and it's still ongoing, but I'm just going to show you the first year of work because it kind of gives a good basis as to what we did in the following years. So this work has been conducted at UCD only, so we're not looking at side effects at the minute. What we're looking at is timing, so 100% applied pre-sowing in the seedbed, or splitting that, so applying 50% in the seedbed and 50% at V6, V8, so once the maize emerges out of the film. So I guess common practice in Ireland is that all chemical and organic fertilizer gets incorporated into the seedbed. So I guess if you split that, will you get a better uptake and use of fertilizer at a later point in the growing season. With 4 inorganic rates, so 0, 50, 100 and 150 kilos of nitrogen per hectare, and all plots would have received 33 tonnes of cattle slurry per hectare, so that's about an additional 60 kilos of available nitrogen. In 2013, the second application of nitrogen was in the form of granular can, and that was at 10 weeks post-sowing, and the varieties that we used for all these trials was 7905 and green film in 2013. So with regards to dose response to the increase in nitrogen, we found that there was a linear response increase in whole crop yield with the increase in nitrogen rates in 2013, but we didn't find any effect on grain yield. What was interesting was the effect of timing on whole crop yield and crop nitrogen uptake. So whole crop yield on your left-hand side and crop nitrogen uptake on the right-hand side of your screens. The rates of 50, 100 and 150, and then the light blue bars represent all of the nitrogen being applied in the seed bed. And then the darker blue bar represents nitrogen being applied in a 50-50 split, so 50% in the seedbed and then 50% 10 weeks later. So we found that there is a tendency towards a timing effect, particularly at the higher rates of nitrogen, that there was, I guess, a decrease in whole crop yield if maize was applied in the 50-50 split compared to it all being applied in the seedbed, with regards to whole crop yield, but also crop nitrogen uptake, and particularly at the higher rate, a big difference there between the two timing treatments with regards to crop nitrogen uptake. So our thought process on this was that green film is largely intact, still intact at that stage, and that perhaps the maize was acting as a barrier to the granular can at the second application, and that the fertilizer wasn't getting into where it needed to be for growth of the plant. So that resulted in, I guess, experiments being conducted in 2014, 2015, where we continued to look at two timings, so 100% in the seedbed and then pre-sowing or in a 50-50 split, as I explained earlier. The same inorganic rates, so 0, 50, 100 and 150, and still receiving cattle slurry along with that. What was different in 14-15, for the second application we used a foliar source of nitrogen, so N16, and that was applied at V6, V8. We also looked at the two different film types, so green and also Samco yellow. So I guess the reason that we looked at the two different films was that at the time of application, you know, at V6, V8, this is what yellow looks like. So it's very much on the path of degrading towards Samco green is still largely intact. So I guess the idea was through using the yellow film and also using the foliar nitrogen that we would remove the barrier effect, and you get the, I guess, true benefit of the second application of nitrogen. So this shows the results from that work. So on the left-hand side of your screen, we've got whole crop yield, the green lines on the chart being represented by the green film treatment, and the yellow film treatment on the right-hand side. And we've got grain yield as well. So no effect of film on whole crop yield, but there was an effect of total N, so an increase to the 50 kilos of inorganic N per hectare, but no major benefit beyond that, going up to 100 or 150 kilos of inorganic N per hectare. On grain yield, marginal benefit of green over yellow, but no effect of nitrogen on grain yield, again similar to the previous year. Regards to crop nitrogen uptake, that's shown on the left-hand side of your screen. So again, an increase to the 50 kilos of inorganic N per hectare, but no major benefit beyond that. And regards to nitrogen use efficiency, again, a straight line decrease regards to nitrogen use efficiency as inorganic N rate increases. This table shows the effect of the application timing and also the film on yield, quality and energy yield parameters. So we've got here on the left hand side is our whole crop yield, grain yield, starch yield, ME yield, nitrogen use efficiency, and also crop nitrogen uptake. So interestingly, we had no timing by film interaction, so there didn't seem to be, an interaction between application timing and the two film types. What we did see was effects of timing on whole crop yield. So basically the split application of nitrogen decrease in whole crop yield compared to applying it all in the seed bed. So similar to previous year's results, again in regards to ME yield, so a decrease in ME yield applying the nitrogen and split application compared to all in the seed bed. Nitrogen use efficiency, again decrease in nitrogen use efficiency, and a decrease in crop nitrogen uptake of the nitrogen applied in the split application versus it all being applied in the seed bed. We did a lot of non-structural measurements of the maize throughout the year, so chlorophyll meter readings and also the crop nitrogen end sensor, just to, I guess, track the nitrogen content throughout the year in non-structural forms. This shows the effect of inorganic N rate and application timing on chlorophyll meter readings using the SPAD equipment, and days post sowing are shown here. So this arrow represents the timing of the second nitrogen application, which, if you remember, was in the form of N16 or the foliar. And these points here represent the nitrogen treatment. So the purple is our 0 or control, and then the blue is our 50, the greens are our 100, and the reds are the 150 kilos of N per hectare. So what you see there, the red, this represents the 150 split, so a big decrease in chlorophyll meter reading of the 150 split after the second application of nitrogen. And then as time progresses, they start to space out as you would expect. So our control having the lowest reading, and then our red having the highest reading as time progresses. So basically this drop there for the 150, for the second application nitrogen was down to scorch. So we were quite careful in the timing of our application of N16, trying to be quite mindful of applying it in misty, damp conditions, but it still caused some scorch of the leaf at application. So I guess just ongoing and future work on the nitrogen program, we're looking at comparing nitrogen type for the second application, so looking at can versus foliar in a replicated experiment, and looking at yield, chemical composition, insolubility indices as well, and that's in collaboration with Pádraig O'Reilly, who is in Teagasc Grange, who is the national silage expert. We're also looking at seeding rate, sowing rate, and film on yield and chemical composition. And this year we're looking at N-rate timing and conducting on a continuous tillage site. So the work that we did in 13, 14, 15 would have been conducted where the soil N indices would have been about 2 or 3. So a lot of background nitrogen there, which probably resulted in the limited effect above 50 kilos of nitrogen per hectare on an annual basis. So this year we're just in the middle of setting up a new trial where we're looking at a continuous tillage site versus the sort of site that we would have used in the past couple of years, so to really test the N rates, and we're also looking at with and without slurry application. So all that work's been conducted by a PhD student, Eamon Corcoran, and his work is ongoing. I guess the N program work is ongoing for forage, maize and UCD. So in conclusion, from the agronomy work that we've been doing the last couple of years, we've found that there is a geographic effect on production potential, that film produces more maize and of higher quality versus the open, even in good years, that it's important to choose varieties according to site suitability and end use as well, and that at the minute the split application of fertilizer in a film system cannot be advised, but as I said previous, that work is ongoing. So